Okay, welcome everybody. We are here for our virtual tour of outer space. My name's Josh. I'm part of the Morrison Planetarium team at the California Academy of Sciences, and we are currently getting ready for our virtual tour of outer space. We do actually find ourselves already in outer space. Where, you might ask? Hopefully this is relatively recognizable. We are looking down at planet Earth. Now, this chunk of planet Earth might not be that recognizable, mostly because we got a whole lot of ocean. I can see blue from side to side all the way across the world. Over here, you can see a little bit of North America, telling us we were over the Pacific. And when we zoomed in on North America, you can actually see the clouds hugging the coastline all the way along California, something we are pretty familiar with. There are a few spots, though, where you might notice our clouds are coming over the land. And I hate to say it, I am currently trapped underneath that blob right there. We haven't seen actual clear skies in days and days and days. One of the really cool things about the view we're seeing right now is it is showing us an accurate view of planet Earth from yesterday. We have satellites going around our planet giving us all sorts of information, relaying really cool things like news headlines, weather reports, and pictures of cats all the way around our planet. But we're actually getting images taken from above and sent to us here. Now, NASA collects a lot of those images, along with NOAA, who's in charge of keeping abreast of our weather and atmospheric and oceanic changes. And together, they launched a mission called SWOMI. SWOMI takes tons of this information and makes it available, and the software we're using, called OpenSpace, takes all that information and makes it available to you. So if you are interested in checking out our amazing planet from above, this is a fantastic way to do it. You can see tons of wonderful details. Now, I promised you a virtual tour of outer space, and while Earth for sure is technically part of outer space, there are cooler things we can do than just spend time orbiting our own planet, our homeworld. At least I assume your homeworld too. One really cool thing I will actually love to do is check out our next door neighbor, the moon. I currently am very excited about the moon because in just 2 days, we are going to get some of the folks from the Artemis missions to visit us on Facebook and tell us about the upcoming Artemis mission. So if you have questions and want to know about the amazing developments that are going to be happening as human beings plan to return to the moon, this is going to be a great time to ask some questions about people who really might know the answers. Now, human beings have set foot on the moon before. You may recall our Apollo missions were about 50 years ago. And the Apollo missions, the first one, set down right around here. That was Apollo 11. They wandered around on the lunar surface, learned a ton, and brought that information back to us. But if you're up on your Greek mythology, you may recall that Apollo's sister is Artemis. And this time we're hoping that humans will return to the moon, not just a bunch of men. Now, that would be a great step forward for humankind, to be sure. Something I hope a lot of you are excited about. If you're not aware of the Artemis missions, now is a great time to become aware. We are moving into a very active phase for them, where they're hoping to test some spacecraft and really get ready for this next big stage. Now, that's not the only exciting thing happening in the next few days from our solar system perspective. We also have a spacecraft preparing to launch for Mars. So if you are excited, I think it's just about, well, I'm going to get the number wrong, but a number of hours away from our launch, and then an awful long wait. Around February, I think 18th, we should be getting our spacecraft to the surface of Mars, where it can start telling us about some of the really cool things going on there. This is another mission to teach us about Mars's ancient past, but where Curiosity has been on the surface of Mars and exploring for years and years and years from Mount Sharp. I think that might be right around here, but I'm not too good with my Martian geography. But that looks like about the right size and about the right shape for Mount Sharp. So let's pretend, if not Mount Sharp, this would be something that's a pretty close analog. But as Curiosity's been exploring, it's been trying to explore the past from the surface. Now, as we send Perseverance, we're going to hopefully get a different kind of insight, because Perseverance is not only a rover, it actually has a little tiny quadcopter drone that's part of the mission as well, designed to take off and fly on Mars. I believe this will be the very first time something has flown in the atmosphere of another planet. Other objects might have dropped in or sailed around, but to actually fly on another world might be a first time. It's always cool when NASA accumulates firsts, something to give us a little boost of national pride. When we look at the surface of Mars, this is a place very different than Earth, though. The air is much thinner. You would need gigantic wings to fly there, somewhat mitigated by the fact that gravity is slightly lower. If you were a 100-pound person on Earth and you go to Mars, you only weigh 40 pounds. It's about 2/5 of Earth gravity. That means you could jump a little higher, maybe jump a little farther. But if you've watched movies like John Carter of Mars or Superman, where all of a sudden you get superpowers, that's a little different. Not quite to that degree for sure. But looking around on the Martian surface, you can see those faint features shrouded by that thin atmosphere, that yellowy glow, especially on the outside edge. So I've taken you to some of the cool spots we're talking about, especially in conjunction with the Artemis missions. But if you have a place that you think would be great for us to visit today, please throw it in the comments. I love suggestions and would be eager to hear where some of you are thinking about traveling to. It is always a great idea that come from our guests. So if you've got something you want to check out, please let us know. Okay, let's see. So we are backing away from Mars. Let's go check out another potential spot for a mission one day, because it's something of an absence in our knowledge. Let's head to the outer solar system. Going to visit the planets that are farthest from the sun is always a cool thing to do. Right now, we are blasting off from the inner solar system that usually describes Mercury, Venus, Earth, and Mars, out to about the asteroid belt. The middle region of the solar system, some would define as Jupiter and Saturn, but others would actually include this planet, Uranus, inside the middle region of the solar system. That might seem a strange conclusion. It's the second farthest planet from the sun. Well, Uranus is very far. Way out here, you can, if we point in the direction of the sun, see the sun is bright, but not exceptionally bright. Now, you can see it right there. When we turn back to Uranus, you can see sunlight illuminating the outermost surface, this bluish layer with those dark features like clouds and yellowy features at the poles. Uranus is a beautiful planet. Now, for Uranus and Neptune, we know a little bit about the planets themselves. If I could pick a mission for us to send out into space, it would be a moon explorer for Uranus and Neptune. Maybe one per planet, or maybe one could visit both. Depends on where they are in their orbits. But I do think that going to visit these outer parts of the solar system, and specifically those moons, would be something really cool. But speaking of outer objects and moons, I saw a suggestion for Pluto. Now, going to visit Pluto is something I feel like we do every tour, because it is such a... Oh, that's not Pluto. That's still Uranus. Okay, for real this time, going out to see Pluto. Heading out to Pluto, it's something that we do a lot because people are so interested in it, and because we have such cool images of it. You could spend hours just looking at the surface of Pluto, and you would still be discovering more interesting stuff. So let's take a moment and really just breathe Pluto in. And Pluto does have an atmosphere, just not one we would want to breathe in. When we go down to the surface of Pluto, one of the coolest things about it is that we actually have topography, measurements of height on the surface of Pluto. Now, when we're looking at the surface of Pluto, you can actually get to see some of these ridges and cracks, some of these dark filled-in craters that actually look quite a bit like craters we see on the moon, where lava has flown in and covered up the bottom of that feature. Now, looking around here, the rock of Pluto isn't rock as we know it. This solid outer surface is actually water ice. And it's possible some of that water ice melted to liquid water and froze very soon after. Out here, temperatures are very low. But that would describe a similar kind of feature that we have on the moon. What I think is more likely is there are dark carbon-rich compounds on the surface of Pluto, and maybe they've moved into and accumulated on the bottom of those craters you see down here, filling up that region in kind of a sheltered area. I'm not sure of the process there, but they are interesting, distinctive features, and ones that I think I would like to learn a little bit more about. Now looking at these cool crack features, let's zoom up to the other side. You've got like a rift valley over here. When you look at the ice forms on Pluto and the dramatic features they have, there is tons of stuff you could see, and we haven't even hit the most famous features of all. Looks like we got a request for the South Pole of Saturn. That is always a cool one to check out, and one that I feel like I skip past a lot. When we head out to Saturn, we can see the first and most distinguishing feature is, of course, those rings. Now, they look especially cool coming from the outer solar system because you can actually see that bite taken out of them. That is sunlight passing through the rings, and this spot being blocked by Saturn. So you get that strange dark feature. This is the view of Saturn we are much more accustomed to seeing because this is the view we would see from our part of the solar system. Now, if we're looking at the poles of Saturn, we can check out the South Pole right over here, just currently in shadow, but using planetarium magic, I think we can get rid of that shadow, or at least the part that's falling on the planet. Now you can see here this kind of nested bullseye pattern. There's a small circle, a bigger circle, a bigger circle, and an even bigger circle beyond that. That kind of marks off different latitudes. The shadow over here you're seeing is coming from the rings themselves. If you look at the North Pole, though, we can see another bizarre polar feature of Saturn. Check this thing out. When you look at it, you can see an irregular shape. This does not match the South Pole very closely at all. There you've got those nice nested circles. The North Pole has this hexagon inscribed on it. Now, a hexagon is a six-sided shape, 1, 2, 3, 4, 5, 6, and that six-sided shape is a storm pattern, a stable feature that's been there for quite a long time, and we really don't understand the physics behind what's causing that to occur. For a sense of scale, to understand how big this storm feature is, imagine you could fit about 3 Earths across it. Some might say closer to 2.5, but when you draw a sharp line like this, you get a smaller measurement. When you draw it from its widest features, you get a slightly larger measurement. That's the nice part about a not regular shape like this. Okay, so zooming back from Saturn, that is a really cool view. I just love seeing those rings from above. It is so beautiful. Let's see, where else in the solar system would you like to go? One of my favorite objects is right next door, so I'm going to take this opportunity to go visit Titan. Now, when we talk about atmospheres and places that we should send missions to, I think Titan pops up immediately for me. Titan has a huge, thick atmosphere, a thick orange haze, much denser than the atmospheres of Mars or Pluto, but it does have a kind of Earth-like atmosphere. At least in terms of pressure, it'd be about the same as we have here on Earth at the bottom of Titan's clouds. Now, the surface of Titan we're seeing here, not the orange haze, has these dark features, which are probably oceans of something a little closer to rocket fuel than the water we're used to on Earth. We've also got some dark sandy dunes, which blend in some spots. Looking around here, though, you can see the irregularity on the surface. It looked like someone took shears to the side and trimmed off bits of the surface of Titan. It's because of how these photos are taken. When the satellite flies over, I think these were taken by the Cassini mission using radar, they took long strips. And when you stick all those strips together, you get this wild puzzle shape mess that we have here. But I don't want you to think that I'm not a fan of Titan. There are beautiful things for us to see. And when we first got our photos of a probe descending through those clouds, not flying, again, I'm going to stand by my thing that I don't think we've flown on another planet, but in descending through those clouds on a parachute, we got to snap photos all the way down and saw a surface with rivers, lakes, and streams. A lot of the same geological processes we have here on Earth that shape the surface of our world are occurring because of similar forces, what we have here on Titan. I maintain that Titan has a lot more in common with the terrestrial planets than it does with the other moons we see in the outer solar system. It is an object very similar to our own planet. We got a request from Hyperion, from another planetarium professional, who I suspect knows that Hyperion is one of the minor moons of our solar system and not something that we have loaded in with high-resolution data. So I'm going to skip past that one for right now. But Zog wants to know, are there more solar systems? Zog, that is an excellent question with a semantic argument. This is a conversation I've had with a couple other astronomers. When you say solar system, there is by necessity only one, because we have defined solar system as our solar system. And I think that is plainly hogwash. So when you look at this glowing ball right there, that is our sun at its true brightness. When you zoom back, you can see all these other stars. This is one of the coolest things, I think, in OpenSpace, is to fly out to maybe a couple dozen, less than 100 light years, and start zooming around in a big circle. You can start to see all those stars that are closest to our star. Now, are those other stars suns? That's the real question. Yes, they have a lot in common with our sun. If you call them suns, then they could have their own solar systems, because you need a sun to have a solar system. If we call them stars, you got to have exosolar system, extrasolar systems. And these are exoplanets in those exosolar systems. Now, that weird little semantic argument to me is immensely disappointing. To say that, well, ours is the only solar system, those are all other star systems. I would rather call ours a solar system, and these are solar systems as well, and not get so obsessed about what's a planet versus an exoplanet, what's a solar system versus a extrasolar system or a star system. I don't think that's becoming for astronomers. I think the best argument we can make is that there are lots of solar systems. But to truly answer your question, we have a whole bunch of other planetary systems around other stars. All of these blue markers are showing you other solar systems. I just call them solar systems. I messed up too. It happens all the time. And we have every reason to think that this is just scratching the surface, that there is a lot more out there for us to find. Why do we say that? We're not that good at finding these planets, and we have found tons of them, so there have to be more out there waiting for us to spot. Okay. Now, our favorite and second favorite moon this week, someone's making fun of me because I change every single time we do this what my favorite moon is. But I'm going to take us into my favorite this week, which is, actually, I'm going to leave it quiet for a minute. I'm going to tell you a little bit about it while we fly in. And if you think you know the name, please post in the comments. This is the biggest moon in our solar system. It is the only male name amongst the 4 Galilean moons. Those are moons of Jupiter. It has a gray surface. It's icy. It features prominently in one of my favorite science fiction stories, The Expanse. If you think you know the name of this moon starts with a G, put it in the comments. Let's see who gets it. We are heading in. And as we get closer, we are now in our solar system, the only solar system there is, according to some people. We're getting closer and closer. This is, of course, Ganymede. Now, Ganymede is super cool to look at. Look at that icy, again, surface. You can see where objects have slammed into it and created what we call an ejecta feature. For people who have never fought with VCRs, the word eject might not be in our popular consciousness anymore, but it used to be. When you hit the button, the tape would come out. This eject area, ejecta, is where material got flung out from an object slamming into the surface of Ganymede. Now, if you wanted to know what the insides of Ganymede were like, you could land on that plume and analyze it. That would give you a little bit of a hint. There are tons of ejective features, too, where objects have crushed into the surface. You can also see places where the surface has cracked and other material has flown in. We see features like this on Earth without that same kind of color contrast. Our rocks all kind of look the same, if you ask me. But when you look at these features, the surface is splitting apart and new material is filling in, kind of like the surface was pasted back together. That tells us there's some level of activity in Ganymede's past. Maybe not currently, but in order for that to be the case, there'd have to be some activity under the surface. Potentially moving liquid, something like a undersurface ocean. And since the surface has a good portion of ice, maybe that ocean is actually water. That would be really cool. Now, some arguments for Ganymede are telling us that it's sort of a Dagwood sandwich. If you're a fan of old newspaper comics, Remember those gigantic sandwiches, Dagwood? I personally would think of a Shaggy from Scooby-Doo sandwich, but something that's really tall with a lot of layers. There might be nested layers inside Ganymede of ice, then water, then ice, then water for a couple layers down. If that were the case, there could be a lot of water in Ganymede. Normally, when we think of water in the Jovian system, we talk about Europa, and I love Europa. That might be my second favorite moon, but let's see. What else would be a cool moon to check out? We could go and see... Phobos. I am a big fan of Phobos. So to go check out Phobos, we are going to head into the inner solar system, and we are heading to Mars. Now, when we go see Mars, that reddish color, you will notice again, that golden glow of the atmosphere, also super cool to spot. But I'm with Samara. This is going to be a cool feature to check out because Phobos is so different from the moons we have seen so far. Why is that? Well, let's think about those moons. We saw Ganymede, largest moon of the solar system. We saw our moon, a very big moon of the solar system. We saw Titan, second largest moon of the solar system. What about Phobos? Teeny tiny moon of the solar system. This thing is dinky. You can tell that just by looking at it because of its weird potatoey, peanutty shape. It's not round. It's not regular. This is a small object, likely a captured asteroid, that just hangs out around Mars. Now, when we look at the surface up close, you can see a lot of dents and dings from bumping into other objects. Some people think these are relatively recent features, and Phobos has potentially been destroyed and reformed over the course of its history. When you say recent, that could mean like a billion years or something for astronomers. They're pretty sketchy about those time frames. But I'm going to give you my favorite factoid about Phobos. Man, that is an alliterative sentence. So my favorite Phobos factoid, try and say that 5 times fast, is imagine standing on Phobos, looking down onto the surface of Mars. You pick up a little rock, maybe about the size of a baseball, and if you have a good arm, you could throw that rock and it would hit Mars. Imagine throwing a rock from a moon and hitting a planet. It's a really impressive thing to do in the Earth-Moon system. It's a little bit less impressive in the Mars system. But if you were on Deimos, it would be even less impressive. Okay, Zog's got another great idea. Let's go check out Io. This is turning into a moon fiesta, something I am entirely okay with. Our solar system has amazing amounts of cool moons. So zooming out to Io, Io is famous for being obscenely volcanic. We have had some discussion in our planetarium crew about the ratio of volcanoes to surface area, the activity level, comparing it to different chunks of Earth. The factoids here get a little dependent on who you ask, but we can agree there are tons of volcanoes here. I believe hundreds going off at any given moment, and we can see them on the surface. They give us cool swirly features. These are not features that are scientific enhancement to the color you would see. It's pretty close to what you would actually see. A lot of sulfurous yellow, a lot of browns and reds, and dark material spattered throughout. Some areas are lighter than others, but not quite an ejecta feature. In fact, when you start looking, how many distinct craters do you spot on Io? For me, the number is very low. You might be able to pick out a couple, but I can't see many at all. When you look, the round dark features we're seeing are volcanoes. Now, this is so active. There's so much going on the surface. I really don't think an impact feature would last very long. As soon as something struck, a volcano nearby just goes off and covers it up. I might guess that something like this could be an impact feature, but I would want to check with an expert before I made any suppositions officially about it. Oh man, Io is so cool looking. We sometimes say it looks like a pizza, but I've also been using that exact same joke to describe the way we like to show the cosmic microwave background. Looks like limon? I would agree. We got that yellowy color. If we found a green moon, then we could have citrus pairing. An orange moon would be Titan, I guess. It's even bigger. And for a grapefruit, maybe just Saturn without its rings. The size scale would probably be a little off there. Okay, so we are zooming back. We are running a little short on time, but if there are any final questions, I would love to try and answer them. It's always fun to get to visit with you folks and fly around our solar system. I gotta say, it is one of the highlights of my week. When we talk about our solar system, though, there is one last thing I would love to check out. Maybe we go in for the big guy himself, our sun. As we get closer and closer, you can see our sun is very bright. If you wanted to see the sun's surface a little better, we can toggle off that glare and see our sun just sitting there glowing. Now, recently, we've had a very boring sun. And what do I mean by that? Go look up the Solar Dynamics Observatory or any other sun spotter that watches the sun's surface for changes, and we see practically nothing. It is a uniform colored circle. Super boring. Recently, we've had a small cluster of sunspots pop up, and according to one of my astronomers' friend, a second small cluster of sunspots popped up not too much later. This is more activity than we've seen on the sun in quite a while, really underscoring just how boring our sun has been, and that's pretty interesting. We don't know that much about our sun. We've only been studying it for a couple hundred years, and for human lifetimes, that makes for a pretty long observation window. But for stars, that's very, very short. When we talk about our sun's lifetime, we think our sun might live for 10 billion years. Now, what is 100 years compared to that? Practically nothing. We really do want to understand how stars live, how they incorporate their material, how they burn it, the energy they make over grander scales of time. But since human beings just don't live that long compared to stars, we do that by comparing other stars we see. We study them across the nearby part of the universe and really try and understand how stars change over time. We've learned our sun is on the bigger side of total stars, but that's because there's a lot of very tiny stars out there. There are stars much bigger than ours, though. In fact, when you look at the total ranges of star sizes, we'd be on the smaller end of that scale. When you look at all these stars, though, they do have a lot in common with each other. They are overwhelmingly made of the same stuff. They make planets, they incorporate their material to make energy, and eventually that material runs out, meaning the star shuts down. By understanding stars on this really big scale, studying the population of stars across our galaxy, the Milky Way, it gives us a better understanding of the individual stars, including our own. Now, if you live here on Earth, and hopefully you live on Earth, most people do, you might wonder why it's so interesting for us to study something like our sun that is 93 million miles away, and if it does change dramatically, who cares? We're all going to be in big trouble anyway. But it does let us better understand these engines of the universe, the things that are turning hydrogen and helium into energy that light up our surface and give us the possibility of life on our planet. Now, our planet might be looking a little funny to you. It certainly is showing up kind of strange to me. But that's because we've flown across the entire solar system, and I kind of surprised my computer. Give it a couple seconds. I'm sure Earth will return to a more opaque state. But in the meantime, you can see stars through Australia, and that's pretty cool. But with that, I think that is a fun way to end our tour. If any of you have questions or comments, put them in the chat still. We would be happy to answer them days or even weeks after this program has aired. We love hearing from you. From myself and the rest of the Morrison Planetarium, thank you all for tuning in. We love being able to visit you at your home. And stay happy, stay healthy. We'll hope to see you again soon.